Since prehistory, humans have been concerned with finding their way. Seasonally, our nomadic ancestors followed the patterns observed in their natural environment to know when to begin their voyage, and were guided on their journey by landmarks familiar to them, rivers, mountains, and anything else found in the ancient landscape. As reviewed by Ammerman in 2010, the presence of obsidian from Milos in Mesolithic sites from other Aegean islands like Jura and Kythnos, and also from Franchthi in mainland Greece, implies routine navigation across open seas in pre-Neolithic times, possibly as early as the 12th millennium BCE, or roughly 14,000 years ago. The settlement of Cyprus and Crete shows that, soon after, navigation skills had already improved to the point of enabling Eastern Mediterranean early farmers to undertake colonizing expeditions involving deep planning and the transportations of groups of people and cargo over maritime crossings in the range of 50 to 100 kilometers. The earliest navigation methods involved observing landmarks or watching the direction of the sun and stars. Ancient sailors rarely traveled into the open sea willingly. Instead, they traveled along the shoreline in order to navigate. When that wasn't feasible, sailors would try to observe the constellations to mark their positions. The ancient Minoans, who lived on the Mediterranean island of Crete from 3000 to 1100 BCE, left material in the archaeological record that shows evidence of using the stars to navigate. This technique, using the stars, sun, moon, and horizon together, allowed them to calculate their position. It was, and continues to be, very useful on the open ocean, where there are no landmarks. Navigators must be familiar with the different constellations at different times of the year, as well as the different constellations in the northern and southern hemispheres. The most familiar constellation in the southern hemisphere, for instance, is the Southern Cross. The stars in this constellation are never visible in the northern hemisphere above the tropics. The Big Dipper, a familiar constellation in the northern hemisphere, is not visible in the southern hemisphere. Navigators using this method need a tool such as a sextant to measure the angle between objects in the sky and the horizon. They also need an accurate clock and an almanac giving the position of celestial bodies. NASA and other space agencies continue to use sophisticated celestial navigation for many of their missions outside of Earth's atmosphere. The astronauts and engineers of the Apollo program use celestial navigation to chart their way to the moon and back. The Mars Exploration Rover also uses celestial navigation to communicate information back to engineers and researchers on Earth. While these basic methods of navigation certainly had and continue to have their benefits even in our modern world, there's no arguing that the advent of maps, drawn on paper and designed to provide a reliable depiction of humanity's understanding of the world and the various ways to move through it, became dominant over these methods of navigation. The oldest known maps began to appear in about 2300 BCE, carved into stone tablets. Take, for example, this artifact. More commonly known as the Babylonian map of the world, the Imago Mundi is considered the oldest surviving world map, mundi being the Latin word for world. It is currently on display at the British Museum in London. It dates back to between 700 and 500 BCE and was found in a town called Sippar in Iraq. The carved map depicts Babylon in the center. Nearby are places like Assyria and Elam, all surrounded by a salt sea forming a ring around the cities. Outside the ring, 8 islands or regions are carved into the tablet. The map is accompanied by a cuneiform text describing Babylonian mythology in the regions depicted on the stone. This map, the Mappa Mundi, is currently the oldest in the American Geographic Society's library, and it was drawn in 1452. It is one of only 3 world maps Phoenician cartographer Giovanni Leonardo drew and signed. Jerusalem is at the center of the map, which depicts the European view of the world during the Middle Ages. It was the first map of its time to show clearly defined shorelines of the Mediterranean and Western Europe. The Mappa Mundi could also be used as a sort of calendar. 10 circles showing the dates of Easter for a 95-day period from April 1st, 1453 to April 10th of 1547 surround the map itself. The rings also show the moon phases, the months, zodiac signs, festivals, certain Sundays throughout the time period, and day length. The version of the Tabula Peutingeriana map on display here, and physically on display at the Austrian National Library, is not actually the original, which was created in the 4th or 5th century, but it is a close second, a replica created in the 13th century by a monk. Essentially, this is a road map, the earliest example of what would evolve into the modern road map of the ancient Roman Empire, stretching out 22 feet wide and tracking all of the public roads from the Atlantic Ocean to modern-day Sri Lanka. Each road is marked at intervals that represent a day's travel, which can vary from 50 to 100 kilometers depending on the road. The path leads through more than 550 cities and 3,500 named places and geographical landmarks. For travel distances, this map is great, but if someone is looking for a real geographical representation of ancient Rome, look elsewhere, because the top and bottom were condensed down to fit onto this sprawling chart. Now, this map is a personal favorite of mine. It was drawn by Samuel de Champlain and depicts New France. The site of Montreal is clearly identified. Using information obtained from Aboriginal peoples, he was able to include previously uncharted areas such as Lake Ontario and Niagara Falls. He also made other maps to depict certain regions, including Newfoundland. Although the engraving here was made in 1612, the map was not published until the following year as an appendix to Voyage, Champlain's 1613 account of his journeys. Early maps like these are critical in archaeological research, as they're a great way of visualizing landscapes that have long since changed, and help us make inferences on humans' understandings of the geographic layout of the world that they occupied. The Champlain map, along with the other examples I've shown you, however, wouldn't be considered very useful today, as modern technology and globalization have painted a much more detailed knowledge of our place in space, far surpassing these cartographic artifacts in their accuracy. That doesn't mean they don't hold cultural clout, however, with many collectors actively conserving maps that hold sentimental value to them. Antique maps also fetch a pretty penny at auction. Take, for example, the universal cosmography, according to the tradition of Ptolemy and the discoveries of Amerigo Vespucci and others. This is a printed wall map of the world created by the German cartographer Martin Waldseemüller in 1507. In 2001, the United States Library of Congress purchased the only surviving copy of this map because it was the first to use the name America to describe the New World. They paid a whopping $10 million. Let's fast forward from Champlain's map of Canada in 1613 to just 20 or 30 years ago. If you or your family took a trip anywhere far from home, chances are you had a series of maps, usually stored on the inside panel of your car door or the glove box, that you had to pull over to unfold and read them like a big Sunday newspaper just to figure out where you needed to go. You can still find these being sold in gas stations with their bright yellow covers, although I challenge you to think about the last time you used one of these. With the advent of the internet, some of you may remember sites like MapQuest, which is still operating today, that offered street maps and driving directions, allowing us to print our own custom maps. This was sort of a transition phase in navigation, and it was relatively short-lived, however, as they were far from perfect. Early routing algorithms were imprecise, and drivers still had to pull over on the side of the road to read next steps. If they took a wrong turn, they would end up as lost as they would have been without a map in the first place. As early as the 1980s, GPS, or global positioning devices, were publicly available, but it wasn't until 2000 that precision GPS navigation became available to the public, and I use the word precision lightly, as we all might remember the news reports in the mid-2000s about people driving into lakes and blaming their GPS. The satellite-based global positioning system is actually operated by the United States Air Force, providing geolocation and time information to a GPS receiver anywhere on Earth. It was first developed by the U.S. Department of Defense in 1973 for use by the U.S. military, although an early satellite-based system called Transit had been in use as early as 1960. These satellites orbit just under 20,000 kilometers above the Earth and emit a very weak radio signal that is picked up by receivers. Our receiver's job is relatively simple. It uses built-in information in conjunction with these radio signals that it's picking up from these satellites, and it's able to determine the relative position and distance from it. However, one signal isn't enough, so the global positioning system relies on a minimum of 3 satellites to be able to triangulate the position, which I'll illustrate for you now. Imagine I've just powered up my GPS receiver. After a minute or so, it picks up a signal from satellite A and determines how far away it is from it. Well, we can see that we're probably somewhere in Canada, maybe somewhere in the Arctic or Hudson's Bay, not exactly a precise location, but that's okay. Our receivers also picked up signals from satellite B, which helps narrow it down. We're somewhere in the overlap or intersection of these 2 circles. Once the receiver determines its distance from satellite C, we're able to triangulate our position by determining where these 3 distance measurements intersect or overlap, putting us somewhere near Winnipeg. Now, it's important to note that these satellites aren't just flying around in whatever direction like you see here, but the principle is the same. GPS receivers provide us with the ability to get fairly accurate location information and make many of the things we do easier and more efficient. It gives us hands-free driving directions on the road. It helps us safely navigate the skies, and it has also changed the way that humans wage war. Increasing accuracy, security, and reliability in our location information also opened the door for all sorts of modern technologies like unmanned aerial vehicles. Because of the benefits GPS provided everyday consumers, in the early 2000s, car-mounted and handheld GPS receivers like this one, the TomTom, became really predominant in our society. Many of you might remember having one of these mounted on the dash or windshield of a car. With a database of digitized maps being stored locally on the devices, and with the option to either connect the device to a computer using USB or a removable SD card to update these maps, GPS now played the role of helping humans identify when to depart on their voyage and what route to take. The technology was predominant in society for the past decade or two, but it had faults of its own. Earlier, I jokingly alluded to people blaming their GPS for driving into the lake, but these devices were plagued by slow user interfaces, and even though the maps could be updated, they were quickly outdated due to the constant push and commerce of development. While there isn't a fan base of these standalone GPS devices, they are still used by a number of individuals in the outdoor adventure world who can't rely on cellular signal to use the technology that has dethroned the TomTom or Garmin. Today, when we set out on a trip, we will simply connect our devices to our cars, launch Apple CarPlay or Android Auto, and launch our preferred app, Google Maps, Waze, Apple Maps, etc., and be on our way. With cloud synchronization and availability across multiple devices, we can pre-plan our trips with high accuracy. Because our smart devices are all connected to the internet on the go, they're able to share our speed and therefore determine the amount of traffic that's built up in real time. That helps us determine highly efficient routes, and with the ability to report hazards on the road, these devices are also keeping us safe as we voyage with a ton of real-time but simplified information. Navigation technology has evolved dramatically over the course of human history, and interestingly enough, each iteration of it is still used by different groups of people. Sailors still use the stars to navigate. Adventurers still use standalone GPS, and most everyone that is venturing far from home will carry physical copies of maps in the event that one of these other methods fail. Perhaps, from an archaeological perspective, this speaks to an ingrained desire in humanity to leverage tools to conquer the natural landscape, to find the most efficient routes to places, and ultimately to stay safe on the journey ahead. Thank you, and bon voyage.